So here is a little game I made. So let's play and let you see how it looks like. So start with click the play button, and then I use the four arrow keys to move to the right, left, and if it hits this, it bounce back. And then if I hit up, it's gonna jump up. And if it hits the wall, and it's kind of bounce back as well. And if I have a combination, so I can actually jump over the hurdle and to the other side, and the right, left, and bounce back like this, right? If you just hit the arrow key, it won't jump high enough to get over the hurdle. And but if you click the combination of keys, and you can actually jump over. I'll let you see the code in a minute to find out how to jump over the hurdle. Okay, let's come back to the code. Okay, first of all, I need to explain all the sprite. So this is a little ball, and when you draw the little ball, you can put some gradient. And this is the horizontal, the platform. Take a look at this. Okay, it's pretty big. It covers the whole stage. And of course, I have a stage, right? I just draw something in the background. And there's a vertical, I call it vertical left. It's actually a little strip. You can see a little bit darker color on the left side. And then there's a very, on the right side, a very similar one as well. They're very thin. They only cover the edge of the vertical wall. Of course, there's a little button. Okay. And then let's take a look at the code one by one. On the play, the code is pretty straightforward. When the button clicked, you just broadcast a message called a move, and then you repeat this code by 10 times. Actually, you can make this disappear, but gradually. We can try this. Let's click play. Right, so you can see it's disappeared right away. See it again, right? This kind of effect is disappear, one a little bit but it's pretty fast. You can try to make this effect more obvious by adjust something here. Right? Okay, and then there's no code on this three sprite, right? And then all the other codes is in the ball sprite. Now again, if you're pretty confident, you don't have to continue to watch this video. You can pause here and try to understand yourself. It's not very complicated, but it's and also there's not just one way to do this. This is just one way I come up with, and also I checked the internet to see some people's idea. Uh, it's very helpful. You can try that too. Okay, let's take a look. Take a look at the code one block at a time. So I start with uh, click the play, right? And a message is sent called a move. The move will be received by the ball, and then all the main part of the motion is controlled by the forever. So that means it's actually the program is running, executing this block. Okay, the whole block here. You can see there's a white edge surrounding this block, right? And then look at an easier one first. So the right arrow, when the right arrow is pressed, I see. Let me try. So it start moving, right? Start moving. It's because initially when the bring flag is clicked, it set up a lot of initial value. So you can see the Vx initially was 0, so that's why it's not moving at the beginning. And once you click the arrow, so the right arrow will give 8 to Vx, left arrow will give -8 to Vx. So that's why if you click these two arrows, they're just moving to the right and left. Now why it's moving to the left and right, it's controlled by this sentence right here. Change x by Vx multiplied delta t. Delta t is a variable that controls how much time. In reality, it makes sense to set the time be 1 second. But this program you can adjust accordingly when you see the effect. If you want to move faster, you can make this time bigger, right? But anyway, it's controlled by this sentence. Change x by Vx. Vx is the speed, and delta t is the time. You can speed multiply time would be the distance. Of course, that's horizontal distance. X is the horizontal distance, right? It's a position marker. So if you change x by a positive amount, so the ball is going to move to the right, right? If you change the ball by a negative amount, so the ball is going to move to the left, that is controlled by the velocity. Well, that's why I give a negative speed to the Vx when you click the left arrow, so that if you calculate the distance, it would be negative. So if you change the x by a negative amount, of course, the ball is going to move to the left. So that's how it works. And another thing is, once it hits the vertical wall, and actually is controlled by here. See, if the ball touching the left, uh, the this is vertical left, means this little strip, and then I change the velocity to -4. So that means it's gonna, when it hits the vertical wall like this, and it's gonna bounce back. But bounce back is slower than the original velocity, right? Originally, when you hit the right key, a right arrow is gonna move to the right at 8. Now when it's bounced back, so you can see it's obviously slower, and that makes sense. It's not always bounce back with exact same velocity, right? So you lose some velocity every time you bounce off some surface. Or you can adjust this number. You can make it a -6 or whatever you want. And then this is very similar. If you're touching the right side, so let me get over this. Uh, so let me get over to the other side, and then you can see when you hit the right side, and then it's gonna bounce back, and so that's why I changed the velocity to positive. And another sentence block is called if on edge, bounce back. So this is see, if you go to the edge, see, it's kind of bounce back, but it doesn't really move backwards. That's something you can figure out. And also the bounce back is on even you jump up, you can still change the velocity of horizontal velocities. See, even in the air, you can see you jump up, you can still like go left and right, right? So that's because you always change the x position by that amount depending on the velocity, right? Okay, so the horizontal motion is pretty straightforward. I didn't make it complicated. And the vertical velocity is something, you know, you need to have a good understanding about it. Okay, take a look at this. When the up arrow key pressed, you set up the vertical velocity. You know, this is, I put a Vy. Vy means the vertical velocity in the vertical direction, and I put I means the initial velocity. So, for example, let's make it a stop, right? And if here, if you at this moment, if you click up, see it's very similar to you throw a ball up, the velocity actually is slowing down. So you see it again. So slow it down and come back, it actually speeds up. And actually notice when it comes back, it's actually not always land exactly on the surface. See, right now it's actually land a little bit below the surface. And if you try again, and sometimes it just happens to be, see, this is even more. And try again. Oh, this is perfect. But no, I didn't control where it lands is because this problem. Let's explain this. First, you give the initial velocity right here when the up arrow key pressed. And once the initial velocity equals 40, and then you, of course, the initial time here equals 0 as well. And then it's gonna come here to calculate the V final. So the V final equals V initial plus the AY, and then multiply the time. And the time is originally was 0, right? And also it won't change if it's touching the horizontal. You can see here. So as long as the ball is touching the horizontal, this means the platform. So the time always be set to 0 again. And in that case, you have V initial equals 0, time equals 0. So after you calculate, the V final is always 0. And actually the V final is the current velocity of the ball. So then when you calculate the V final, multiply the delta t, and the change y, it doesn't make any difference. Okay, but every time I'm gonna change the time by delta t, that means I'm gonna increase the time by that much. But if the ball is still touching the horizontal platform, this two will be set to 0 again. So that means the y direction, they won't have any motion as long as the Vx, as long as it's touching, right? If it's touching this, it's not moving, right? So, but if it's not touching, see if I click the first time, uh, uh, the test is not touching anymore. So then this one won't do, and then they just keep going and calculating, increase the delta, the time by that much. So the time is gonna grow, right? Now you can actually look at the time. Let it show. So you can see. Let me press this. You can see the time is increasing. It becomes 0 again once it come back, right? And also you can show the V final, right? So you can see I click. See, now notice the velocity when it comes back, it becomes negative. So that exactly works well when it comes back and changes the y by multiply the v final, a negative number, and by this always positive delta t, and it's gonna creating a distance negative, so that's why it's going down, right? So this is the whole idea that control how the ball can continue going up and coming back, right? And that's a very important part of this program. And yeah, I think that's everything about this. And of course, another thing is if you have the, see, when you go up and if you press the left or right key, now you can actually have these two things working together, the x being changed, y being changed at the same time. So that's why you have this kind of effect, right? Even you want bounce back, it doesn't really affect the vertical direction. See, if you're going up, so you still bounce uh, to the left and also still going up, right? So you can, if you want to understand better, you can actually show all this variable to have a look at how the variable changes over time. Okay, so now that's basically my introduction of the game. And for you, I may ask you to change something. For example, can you figure out how to press the key so that you can jump uh, higher, right? So of course it's done here, right? And you can actually modify the blocks to make it a little bit different, maybe better than this.